All right, we are going to start. So, welcome back, everyone. Hopefully, you had a really good week and Thanksgiving last week. Today, we're going to look at equations. A lot of you probably think this is like review and stuff, but we are going to look at some new material near the end of the slide. The first half is like review for some of you, and then the last half is like a new topic that you guys should learn about. Oh yeah, and before we start, do any of you have any questions from the homework from 2 weeks ago? It wasn't. No, it was not mandatory, but like it's just for fun. It was really. I highly recommend that you do it though. Do any of you have questions about like those problems or not at all? Okay, I guess not. That's all right. So let's start with our topic today. So first, let's look at a few definitions here. We've seen some of these before. So variable is a symbol that's used to represent an unknown value. For example, you use x. That's the most common one. And the second term, constant. So a constant is a value that is already known and remains unchanged. So for instance, any number that counts as a constant, it remains unchanged unless you do some arithmetic with it, like addition or subtraction. So that's what a constant is. It's just a number. Or you can say a constant is a non-variable, like you know the value of it. And then our third definition is a coefficient. So a coefficient is a constant that's in front of the variable. So like a constant paired up with a variable. For example, we could have 2x. So 2x would be 2 times x. So if you have a constant and a variable right beside each other, that means you're multiplying them. And so 2x is just equal to 2 times x. And the coefficient here is 2. So 2 is the constant right here. Any questions about these definitions? No questions. All right, that's good. Let's go on to the definition of an equation. So what is an equation? Equation is just a statement that shows two values that are equal to each other. And we usually include one variable on one or both, like the left-hand side and the right-hand side of the equation. So left-hand side is like the left side of the equal sign, and then the right-hand side is just basically the right side of the equal sign. So for example, we have x plus 4 is equal to 10. And then when you're trying to solve the equation, here are the steps. Basically, you try to first you isolate variables from the constants. So basically, you can move variables to like the left side of the equation, and then you move the constants all the way to the right side of the equation. So you want to separate constants from variables. That's the very first step. And then your second step, well, you could also make this your first step if you want. You could combine any repeat variables, or you could combine any constants together. So like if say you have like 1x or 2x, 1x plus 2x, you can combine them together to make 3x. Same thing for like constants. So you have 1 plus 1, you can combine them to get 2. Oh, did not mean to go back. Sorry. And then lastly, you can solve for the variable. So those are the steps you can use to solve an equation. That should be fairly straightforward. Let's do a few equation problems. So solve for x for the following equations. And just note that x might not have like an integer solution for some of the questions. So keep that in mind. So I'll give you guys a few minutes to solve these. Yeah, 8 times that entire thing. Do you know what the distributive property is? Like, have you heard of that term? No? Okay, I will show you guys. For those of you who don't know what the distributive property is, basically, so you have distributive properties. Basically, you're multiplying like once a single number or a variable by a term in brackets right here. So you have 8 times x plus 3. So what you do here is that so you're trying to get rid of the brackets. So how do you do that? You just multiply 8 by all the terms that are inside this bracket. So 8 times x, right, is 8x plus 8 times 3, or 24. So that's how you expand those brackets. Any questions about that? Or is it clear? Hopefully that makes more understandable. That's what the distributive property is. Yeah, so I just rewrote it here as ax plus 24. Okay, I think we can take these up now. So does anyone have the answer for the first question? Yep, go on. It's 48, not 12. Yeah, because look, so you want to move this negative 18 to the right side, right? You want to get rid of the, because it's a constant and the variable's here, and there's a constant on the right side. So you want to move this constant to the right side as well. So if you want to get rid of it here, you have to add 18. So negative 18 plus 18, that'll give you 0, and you're just left with x on the left side. And then on the right side, you'd have 30 plus 18, because you want to keep the two sides balanced. When you add 18 to the left side, you have to do it to the right side as well. And so that gives you x equals 30 plus 18, and 30 plus 18 is 48. So that was fairly straightforward. Does anyone have an answer for question 2? Yep, go ahead. Yep. Sorry, I hear a lot of background noise. Could you stop that? I hear some background noise from you, Patrick. Yeah. What's the answer? That was someone else can say the answer if you want. It looks like it stopped. X equals 4. Perfect. Yep. So let's, yeah, we can solve this on the canvas right here. That 4 looks that 4 doesn't look good. Let me see. Okay, here. Let's first erase this one. Right. So what? 4x minus 5 equals 11. Okay. So first things first, we notice that there's a variable on the left side, but a variable with a constant. And then there's a constant on the right side. So that means we want to move the constants to the right side. So we're going to move this negative 5 over here. And how we do that? We just add 5 to get rid of the 5 over here. And we have 11 plus 5 on the right side. So then 4x equal to 11 plus 5, which is 16. And we're not done yet because this is 4x. We want to look for x by itself. So what do we do here? We just divide by 4. And same thing with the right side. X equals 4. Right? Any questions about that? Okay. How about question 3? Anyone have an answer for that? Negative 18 looks correct. Yeah. And I'll go for it again. Oh yeah, this takes up a lot of space. Let's save space over here. So 7x plus 10 equals negative 3x minus 170. Okay, so you notice on both the left side and the right side, they both have variables and constants. So here we can choose where to put variables on left side or right side. So that doesn't matter. For simplicity's sake, we should let's put them on the left side. So we're gonna move this negative 3 over here, and you basically just add 3x. So like that. And you can show us, and then you have to move this constant, so plus 10, to the right side over here. And you can just show this in one step. That's perfectly fine. I've seen that in schools, and they give you marks for that. So to move the plus 10 to the right side, you just subtract 10 on both sides. Mm-hmm. Oh, like you can like move when you're trying to move multiple things at once, you can do that in one step. So like if you're trying to move a variable to the left side and a constant to the right side, you can do that in one step. Unless it's a bit confusing to you and you need to show it out, but that's all right as well. But does this make sense though? Okay, I guess I'll move on. So now we have 7 plus 3x. This will give us 10x. Okay. So 7 plus 3x is 10x. Here we have, let me cross these out. Here we have negative 170 minus 10. That's negative 180. And so now we have to, now we divide both sides by 10. Not going to show it here, but this should give you x is equal to negative 18. So that's how you get the answer for question 3. All right, what about question 4? Anyone have the answer for that? Does anyone solve question 4? Half. Yeah, I think half looks correct. Let's do that right now. So here we have a fractional answer, but here, let's solve it. So 8x plus 24 equals 28. First things first, you move the 24 to the right side. Sorry, that arrow looks bad, but hopefully you understand that. And we can move it by subtracting 24 from both sides. Right. So that is gone. Oh, someone string. Oh, hello. Hello, Yifang. Let me add you to the attendance. Okay. So yeah, we were just discussing equations. Hopefully it's reviewed to you, Yifang, but not. Here's some you look at. And we were just solving question 4 right here. So ax plus 24 is 28 over here. Okay, so we moved the 24 to the right side by subtracting 24 on both sides. And here we're left with ax is equal to 4. So 28 minus 24 is 4. And to get rid of the 8 on the left side, we have to divide by 8. So this would be x is equal to 4 over 8. And if you know how to simplify fractions, this would be 1/2. So basically simplify it by dividing the top side and the bottom side by a factor. And by the greatest common factor, actually, which is 4. So 4 divided by 4, 8 divided by 4, gives you 1/2. Okay. Does anyone have an answer for question 5? So again, I have to express express x in terms of y. So x is not going to equal like just a number. It's going to have to equal something with y. So anyone have an answer for that? Yeah. Yeah, perfect. X is equal to y plus 1. So how do we get that? Let's save some space right here. 4x minus 4y is equal to 4. Okay, so we have variables on the left side and the constant on the right side, but we're only looking for the value of one variable, right? We're only looking to solve for x. We don't want y, So in this case, we can move the y to the right side since we're not solving for it. Hopefully that makes sense. So we're trying to move y to the right side because we don't need it. We can treat it as a constant, even though like it's not a constant, but we can treat it as a constant because we only want x. So to move 4y to the right side, you can just add 4y to both sides. So we get rid of this, and now we have 4 plus 4y. I'll rewrite this as 4y plus 4. Usually I like to put the variables first before the constants. It just looks nicer that way. All right. And then if we want x by itself, we have to divide both sides by 4. So divide by 4, and 4 here is gone. So now we have 4y plus 4 divided by 4. And so when you divide multiple terms by a number, you can divide like each of the terms individually by that number. So you can do 4y divided by 4 plus 4 divided by 4. And so that'll leave you with y plus 1. Does that make sense to you guys? Okay, hopefully that makes sense. Anyone have an answer for question 6? So we have x, y, z. So x times y times z is equal to negative 90. Anyone have an answer for question 6? I'll write down over here. So x times y times z is equal to negative 90. So remember, we're trying to solve for x, and here you can treat y and z as the constants. So I treat them as just numbers that you already know. And you want to get rid of them from the left side. So how would you do that? Does anyone know? Perfect, yeah. So you want to divide the left side by yz so that you basically get rid of it from the left side. So those two variables are gone now. But you have to also divide it on the right side. So you have negative 90 over yz. Let me rewrite that over here. X is equal to, now this would just be a fraction. You can't really simplify it any further. So we just write negative 90 over yz, just like that. Don't need to simplify it. And also you can put the negative sign in front of the fraction instead of just putting it in leaving it in the numerator. I think this looks nicer than that. Does anyone have any questions about these problems? Anything that I need to repeat or anything? No? Does everyone understand how you solve these problems? I guess we'll move on then. Oh, go ahead. Which question are you talking about? This one. That's the very last question, question 6. Right here. Yeah. Okay, hopefully that makes sense to you. No problem. Now let's move on with the with the lesson. So now we can talk about equation. Now we want to talk about equations with multiple variables. So an equation with more than one variable, just a single equation, if it has more than one variable, such as like 4x minus 4y, here we have two variables. The equation with more than one variable can have multiple solutions on its own. Example here, we have x plus y is equal to 5. And if we try to find all the solutions to this equation, we can find that there are like infinite number of solutions. So we say we could have 1 comma 4. So here x is 1 and y is 4. 1 plus 4 is 5. We could also have 2 and 3. 2 plus 3 is also 5. We could also switch the numbers around. So instead of 2, 3, we could have 3, 2. That's a different combination. 3 comma 2 is also equal to 5. And etc. The list goes on and on. And you can see how there is an infinite number of solutions to this equation. But we want to look for an equation with only one solution. So for an equation to have only one solution, it must be paired up with other equations. So we call this a system of equations. And a note here is that the number of equations, like a number of equations that you need to get one solution only, must at least be equal to the number of variables in order to get one solution. So basically, the number of variables you have also determines the number of equations that you must have to get one solution. Are there any questions about that? No questions? Okay. And you could also have more equations than you have variables. That's possible as well. And if you when you and then now we're trying to solve how figure out how to solve these systems of equations. And there are two main methods which we can use. First, we can do substitution. In substitution, you can solve for one variable in terms of the other variable and the constants, and then you can substitute that value into the equation. I'll show you guys later what that looks like if you haven't seen it before. And the second method is elimination. So you can add, subtract, multiply, or divide the equations. Usually we just add or subtract. That's what we're going to focus on for today's topic. But you can also multiply and divide them in some cases. But we won't do that in today's lesson. So you can do arithmetic to the equations to get rid of one variable. So you can solve for the other. And I will show an example of that as well. So this is what substitution would look like. And here are the main steps, the general steps that you would follow. So first, you have to choose a variable where you can easily isolate choose an equation where you can easily isolate one variable. Now, so we can go along the example as well with these steps. So example here is we have equation number 1, which is y equals x minus 1. Equation 2 is equal to 2x minus y is equal to 0. And if you want to check if this is solvable, like it only has one solution, you can see that the number of different variables is 2. Number of equations is 2. So therefore, it must have one equation because the numbers are equal to each other. So we're trying to choose an equation where you can isolate one variable. Here we're going to choose 1 because it's already isolated. Isolated means like the variable is on its own on the left side or right side. And here we have y is equal to x minus 1. So y is the isolated variable. We don't need to touch that equation anymore. And for the second step, you have to solve for that variable in terms of the other variable and constants. So we were talking about equation 1. We already had this step done for us. So y is equal to the other variable and subtracting a constant. So it's perfect. We skip step 2. Step 3 is that you have to substitute that variable's value into the other equation. So what I mean by substitute is that you take like the value of this variable, so like the right hand side, which is x minus 1, and then here you can substitute it into the second equation right here. So instead of having 2x minus y, you have 2x minus, in brackets, x minus 1. So I put this value for y in question 2. And this way, I'm left with only one variable in this equation. And now I can solve for this variable. And that's what step 4 is. You solve for the other variable. So here we are solving for x in the second equation, equation 2. And if you try to solve for that, you're left with x plus 1. So this minus sign gets distributed to both the x and negative 1. So you have 2x minus x and plus 1, because these two negatives cancel out to make a positive. So when you have x plus 1 is equal to 0, if you solve for that, you get x equals negative 1. So you just move the plus 1 to right side by subtracting 1 from both sides. And then step 5, the final step, you can substitute this variable's value into one of the original equations. And original means that like the equations that you were given in the question, like the equations that weren't modified at all. So you can substitute this into one of the original equations to solve for that variable that you isolated in the beginning. So here we have x equals negative 1. You can substitute this into equation 1 or 2. In this case, we chose equation 1, so over here. So now we have y equals -1 minus 1. So x was over here, but we substitute that with -1. So y equals -1 minus 1, which is equal to -2. And then we can write our solution like an ordered pair. So an ordered pair means like you have x comma y. So and x comma y is equal to -1 comma -2. So here's x, which is -1. Here's y, which is -2. Right, like a pair like that. Are there any questions about substitution? No questions? Okay. Now, assuming you all understand this substitution. Now let's look on the second technique for solving system of equations. This is called elimination. So let's go through step 1. So step 1 is kind of similar to step 1 in substitution, but this time you have to choose a variable to remove from both equations. So like you want to get rid of x or y from both 1 and 2, equations 1 and 2. So here we have equation 1, which is 3x plus 7y is 15. Equation 2 is x minus y equals -5. Step 2, this is like an optional step, but so if you need it, you have to multiply or divide one or both equations by a constant. So that way you can make the variable that you want to eliminate have the same coefficient in both of the equations. And why do we do that? It makes it easier to get rid of that variable. So over here, we can multiply equation 2. Actually, first, say which variable we want to get rid of. Here we want to get rid of x. To get rid of x, we have to make sure that the coefficient of x in both of these equations are equal to each other. And so that means we can multiply equation 2 by 3 to get 3x minus 3y is equal to -15. And now we have 3x in equation 2, 3x in equation 1. Usually I would rewrite this equation as like equation 3, but it looks like I forgot to do that in this step. I would usually put equation 3 over here because it's kind of a new equation. It's different from equation 2. But here I'm just going to call it equation 2 because why not? But don't do that at school. So yeah. And now we can subtract equation 1 from equation 2. So we can subtract these terms from these terms over here. And that way we get rid of 3x. So the way we subtract these equations, we can line up the terms that are that have the same variable or the constants. We can line them up and we can add or subtract them. So over here we have so equation 1 minus equation 2. First we have 3x minus 3x, and that's equal to 0. So we basically got rid of the x. We have 7y minus -3y. Minus -3y is the same as adding 3y. So we have 7y plus 3y, and that gives you 10y over here. And on the right side of the equations, we have 15 minus -15, or 15 plus 15, and that gives you 30. So now we're left with this equation, 10y is equal to 30. And now you can solve for this. So you can solve for the variable y, because one variable, one equation. So now you divide both sides by 10. And so you're left with y is equal to 3. I think I forgot to mention step 3, which is you subtract the equations to get rid of the variable and solve for the other variable. Actually, I think I went over that. But now we're final step, step 4, is you substitute that variable back into one of the original equations and then solve for the other variable. That's basically the same as the substitution step. So step 5 right here is equal to step 4 for elimination. Nope, there's someone else joining. Not John. Wait, sorry, not John. What's your actual name? Could you repeat it? Oh, Devin. Okay. All right. Thanks, man. Yeah. So no, it starts at 1:30. Remember that for next time. Okay, just doing the attendance right now. Where is it? 0 right here. All right, I'll remember that for next time. Okay, so remember step 4 is you substitute the variable. So here we have y is equal to 3. You can substitute into equation 1 or equation 2. Just substitute it in the equation that's like easier to solve because, well, it'll make your life simpler. So we can substitute in equation 2. So by doing this, we get x minus y. Y is 3. So we can have x minus 3 is equal to negative 5. And to get rid of the negative 3, we can add 3 to both sides. So now we have x is equal to negative 5 plus 3. And that's equal to negative 2. And our final solution is x comma y is equal to negative 2 comma 3. That's our answer for this question right here. Are there any questions about this? No questions? Okay. And then we're going to look at how you can implement systems of equations into word problems, because these show up a lot in math contents problems. So you want to make sure you understand how to solve these kind of problems. And basically, the strategy is you assign variables to unknown values in the question. So I can say let x is equal to like the variable that we want to solve. You can also have let y is equal to another variable. And step 2 is that you have to write 2 or more equations that relate these variables according to the problem. And I can show you guys an example of that later. And the step 3 is you just solve for the variable, the two or more variables, all the variables using substitution or elimination. Right, so that's the strategy. Here we're going to look at a problem for a system of equations. So let's say in the grade 5-6 Olympic math class at Grand River High School, there are 4 times as many boys as girls. I just made up that fact just for the questions. And yeah, I am assuming that it's. I don't think that's the actual statistic, but I'm just making it for the question itself. So yeah, if there are 30 students in the class, I also made that statistic up. How many girls and boys are there? And let's actually solve this together. Let me make a new template, new drawing. Okay, so our first step is to assign variables to the unknown values that we want to solve for. So the unknown values are like the number of girls and the number of boys in this Olympic math class. So the most common variables we use are x and y. So let's do that. So let x be the number of boys in the class. And for number of girls, we can use the variable y. Okay. And so we have 2 variables. We want to figure out 2 equations so that we can get one solution for x and y. So I'm going to write equation 1 over here, and then equation 2 over here. Oops. All right. Oops. Okay. Sorry about that. Okay. So we want to figure out 2 equations that relate x and y. Can someone give me one equation? Perfect. X plus y is equal to 30. So in the question, it said the total number of students in the class is 30. And the way you get that, you can add the number of boys in the class with the number of girls in the class. Unless there are other genders, of course, but in this case, assume there's only 2 genders. So x plus y is equal to 30. Okay, how about a second equation? Anyone else have that? So let's use this fact here. There are 4 times as many boys as girls. Close, not 4x equal to y. Yeah, 4y is equal to x. I'll explain why is it. Okay, so we're here. Here it says there are 4 times, like 4 times more boys than girls. So x is 4 times larger than y, and so we multiply 4 to the y instead of the x. So just don't get that fact confused. You multiply 4 to the smaller number instead of the bigger number. So just be careful of that. Okay, and now we can solve for x and y. Here we're going to use substitution because we can substitute x into equation 1. So like that. So, and when we substitute, we get 4y plus y is equal to 30. I'll show that again. So we substituted equation 2 into equation 1. So in equation 2, we're given the value of x, which is equal to 4y. And so we can substitute the 4y into equation 1. So that we get rid of x, and we're just left with the y's, which we can solve for. So here we can add these two y's over here, two y terms. So 4y plus y, that gives us 5y. Okay, 5y is equal to 30. To get y by itself, you can just divide by 5. So y is equal to 30 divided by 5, which gives you 6. So now number of girls is 6. So we're almost done. The problem, now we have to solve for the number of boys. So we substitute this equation into equation 1 or equation 2. We can do it into equation 2 right here. So 4 times 6 would be equal to x. Right. So x is equal to 4 times 6, which is 24. So then our final solution is that there are 24 boys and 6 girls in the Olympic math class. Are there any questions about this? No questions? Okay, let's move on to some spicy stuff. Here's something new that you've probably never heard before. It's called Diophantine equations. So Diophantine equations are these special equations that only account for integer solutions. And the word Diophantine comes from this famous Greek mathematician named Diophantus of Alexandria. I mean, he might not be famous, but he's a really intelligent mathematician in ancient Greece. So yeah, that's all you need to know about him. That doesn't mean he's not important, of course. It's like you're saying like I mean, true. I guess yeah, true. I mean, there's a lot of like Nobel Prize laureates or like Nobel Prize winners who do like really important stuff, but that you might not know their names of. So yeah. But yeah, okay, let's move on. And usually these Diophantine equations, they consist of more than one variable. And they usually have the form ax plus by, so a times x plus b times y is equal to c, where a, b, and c are constants. So a, b, and c, a, b, c are not the variables in this equation. The variables are x and y. A, B, C are just constants, which you can substitute into. So for example, we have 3x plus 4y is equal to 12. And if you can see, you can notice that this equation will have multiple solutions. Oh, I hate this bar that appears here. Let's get rid of that. Okay. So you see 3x plus 4y is equal to 12 has multiple solutions. Some of the solutions are 0, 3, 4, 0, 4, negative 4, 6, and the list goes on. So are there any questions about this so far? You guys understand what Diophantine equations are? And there are multiple forms of Diophantine equations. So we can have like a squared plus b squared is equal to c squared. That's famous Pythagorean theorem. That's also a Diophantine equation. But we're only going to look at the equations with this format. So ax plus by is equal to c. Right. Now here's a famous identity. Oh, sorry, I used the word famous again. Might not be famous, but here's a math identity that's very helpful when solving for Diophantine equation problems. So this identity called Bezout's identity, it helps you determine if a Diophantine equation has any integer solutions or not. So Diophantine equation, it can have multiple, like infinite number solutions, and it can also have zero integer solutions as well. So the identity goes like this. Let a and b be whole numbers. So integers that are larger than non-negative integers. I'll just call that integers that are positive, and that includes zero as well. So let a and b be whole numbers, and let c be the greatest common factor of the two. And so hopefully you guys remember how to solve for greatest common factor of two numbers. That was from the lesson 2 weeks ago. Should be reviewed. So c be the greatest common factor of a and b. And so one statement that the identity makes is that there must be integers, x and y. Like these are variables, but they have to be integers. They can't be decimals or fractions. There must be integers x and y such that ax plus by is equal to c. So that's one statement of the identity. And the second statement of the identity, in addition, there exists integers x and y. Let's assume these are different integers from here. Let's assume these are completely different from x and y over here. So there exists x and y such that ax plus by is equal to some integer n. Hate the black this bar that comes over here. Let's get rid of it. So say we have ax plus by is equal to n. And this can only be true if c divides n, or n is divisible by c. So the statement at the bottom right here. Are there any questions about this? It's probably really confusing for you guys. So if there are any questions, go ahead and ask. No? Yeah? Wait. Wait, sorry, Patrick, I can't hear you. Can't hear you, Patrick. You can type your question in the chat. Just do that. I'll wait for you. It's fine? Okay. Okay, so hopefully you guys understand what this identity is about. But in conclusion, it's just you use it to determine if an equation has integer solutions or not. So just keep that in mind. Right. And here we're going to look at how you can find all of the integer solutions, like a efficient method to find all the integer solutions of a Diophantine equation. So to find all the solutions of, say, ax plus by is equal to c, step one, you can use trial and error to find just one solution of the equation. So we can just like find random values of x, find random values of y that work. Or you can do that algebraically by like just get one value of x. So you can say x is 1, and then use algebra to solve for y. Now to get other solutions to this equation, you can add or subtract b to x. So x plus b or x minus b. And do the opposite to for a to y. So say I have x plus b. For y, I have to do y minus a. And if it's x minus b, I have to do y plus a. So you do that to find the other solutions. So x plus b will be the new x, like a different solution, the x for a different solution, and then y minus a. Sorry, y minus a would be the y for a different that solution as well. And then final step is you can use step 2 for all of the solutions, like all of the solutions that you've got. You can do this recursively. So you can subtract b to the new x, and then you have to subtract a from the new y. And we can go through an example over here. So say we have 3x plus 9y is 27. Here, first thing we have to do is figure out if there are integer solutions to this equation or not. Oh, sorry, who whistled there? Hey, please stop that. Thanks. So we have, we're trying to figure out if this equation has integer solutions. So you have to find the greatest common factor of 3 and 9. And this should be pretty straightforward. GCF of these two numbers is 3. And so now we have to figure out if 27, so like the value of c, is divisible by this greatest common factor. And it is. So 27 is divisible by 3. Since we know that, that means there have to be integer solutions. And they're probably an infinite number as well. So we can find one solution. So one solution would be 3 comma 2. And just to double check that works. So you can do 3 times 3, which is 9, plus 9 times 2, which is 18. 9 plus 18 gives you 27. So that is one solution. Here we can use step 2 to get two other solutions. One solution is 12, negative 1. The other solution is negative 6, 5. And here I show steps of how I got those numbers. So 12 would equal x plus b. So x is 3 over here, the 3 over here. B is a coefficient of the y, which is 9. So we have 3 plus 9, that gives you 12. Negative 1, so this is the y for this solution. That's equal to y minus a. So y would be 2 from here, and a is the coefficient of x, which is 3. So 2 minus 3 gives you negative 1. Now you can do the opposite for this solution, negative 6, 5. You can do x minus b to get negative 6. And for 5, you can do y plus a. Right? And so these are two other solutions for this equation. Are there any questions about this? No questions. All right. Let's try to solve two problems right here. So find 3 integer solutions to each of the following equations. I'll give you guys a minute or two to figure this out. Okay, wait a few more seconds. Okay. All right. Yeah, of course you can. Okay, I think we're going to take this up now. Let's look at question 1. Get a new drawing for that. So 10x minus 12y is equal to 14. Like type it out. A text box. I'm not sure how to get text box in here. Um, mm. Oh, okay. Oh, I see what you mean. Okay. Okay. The jam is only shared to the chat, so that's a little bit awkward. That like people have to just click on it over and over. So yeah, I think I'm gonna stick to this canvas for now, but I'll try to look for like better solution, like better whiteboards to use. So yeah, thanks for that, Eric. Um, okay, so first we have to figure out if this has integer solutions or not. So can someone tell me what the greatest common factor of 10 and 12 is? Ignore the negative. We can just take the positive version of negative 12. What's the greatest common factor? 2, right? Perfect. And is 14 divisible by 2? Just someone say yes or no. It is. Perfect. Okay. So that means that this does have integer solutions because we use Bezout's identity. Right. Can someone give me one solution to this equation? So give me one pair of x and y. Just any pair. You can shout it out. Let's see, 4 and 2. So 10 is 4, 40 to 24. I don't think that works. No. Try again. Here. I'll think. Just one x and y pair, like any x, y that satisfy this equation. I can give you guys one actually. 5 comma 3 should work, right? So 5 times 10, 50. 12 times 3 is 36. 50 minus 36 gives you 14. So this is one solution. Now, if we can, now we're trying to get other solutions as well. So we have to add, I'll put A, B, and C over here so that makes it more understandable. So now we have to add X to B, or we can subtract it. In this case, let's let's add it. So 5 plus negative 12. That will give us a new X for another solution. So this is negative 7. Now we have to subtract y and a from a. So y minus a. So we have 3 minus 10. And that also gives us negative 7. And we can test this out in the equation, see if it works. So 10 times negative 7, negative 70. Negative 12 times negative 7. That gives us positive 84. And you can see that this indeed adds up to 14. So negative 7 is also a solution. Can someone give me a third solution? So we can switch this to minus 12, and we can switch this to 3 plus 10. Can someone give me another solution? 17 and 13. So yeah, 17 and 13. Perfect. And we can test that out. Let's see, 10 times 17 is 170. 13 times 12 gives you 156, I think. Yeah, 156. And looks like that's equal to 14 as well. So perfect. So these are 3 solutions. So 5 comma 3, negative 7 comma negative 7, 17 comma 13. Okay, what about question 2? Are there any solutions to question 2? First, figure that out. Someone say yes or no. Remember, we're looking for integer solutions only, and we have to use space-Zoo's identity to figure that out. Yeah, there isn't. This is a trick question. Because, so, what's the greatest common factor of 14, 16? Someone tell me. 2. Perfect. Is 11 divisible by 2? And is 11? C is 2. No. 11 is not divisible by 2. So this means that there cannot be any solutions to this equation. So we'll just leave it like that. So there are no integer solutions to question 2. Are there any questions about these two problems? Okay, guess we can move on. It's going to do 2 more problems. Okay, so here's a word problem, and there's a system of equations. So here, Kevin just developed a new mobile app called Unspotify, which lets users download music but at a small fee. So his app is basically a scam. When he checked the statistics for a BTS song, the BTS is everyone should know this is a K-pop group, and the cost of this K-pop song is 75 cents. And when you check the statistics for a Twice song, Twice is also a K-pop group, you guys should check it out, and the cost is 50 cents. He noticed that both songs were downloaded a total of 200 times, and he gained a total revenue of $130 from these 2 songs alone. How many users downloaded the Twice song? Well, let's just go. I actually kind of do hate K-pop as well, but it allows you to solve the question. Because I don't know. I think it would appeal to most of you guys, but I guess not. So whatever. I tried. You're not fine. Okay, I see. I see. I see. Okay. hmm Okay, I won't argue with the opinions right now, but let's just solve the question. Let's ignore K-pop stuff. So let's have 2 variables. So let x equal, trying to figure out how many users download the Twice song. So let's x equals number of uh, Twice downloads. Let's just call it number t. Let's keep it short. We also need another variable. Even though we're not trying to solve for this, we still need this variable so we can solve for x. So let this be number of BTS downloads. In total, yeah. So do you know, so now we're trying to figure out 2 equations to relate these 2 variables. So give me one of the equations. Call this equation 1. I want to figure out one equation for this. Yeah, so we have number of total downloads for these 2 songs is 200. So what do you do with x plus y? Sorry, I gave that away. What do you do with x and y? Yeah, there you go. So remember, this x is number of downloads for the Twice song, y is number of downloads for the BTS song. So total number of downloads for these 2 songs, we just add them together. Simple as that. 200. Okay. Now we have another fact. He got a total revenue. So so these the cost for the songs contributed to Kevin's money. So he gained $130 from these 2 songs. So how do we express that as a second equation? Oh yeah, x is Twice. Yep. Y equals 130. Perfect. So you multiply the